This is Chris with PD&D TV, and we're at the National Instruments booth here with Hunter to talk about some of their involvement with FIRST. Can you tell me about the projects that you're involved with, specifically the automated car that you were speaking with me about yesterday?
Absolutely. So National Instruments has been very involved in FIRST for several years now. You know, obviously with our partner with Lego and the Lego Mindstorms NXT, we've been working with them for years. And then a few years ago, the FRC teams moved up to the Compact Rio controller. So you know, we're very involved in FIRST in that way, and we're happy to have this booth here to help tell the story of engineering and kind of where they can go from here. So one of the ways we do that is through our organization called Waterloo Labs. Now, Waterloo Labs is kind of an outlandish outreach part of National Instruments. It's not focused on making money or making anything practical. Instead, we're just focused on making engineering and science fun. So we've done a wide variety of projects, all using LabView and a wide variety of hardware. And each project's been very unique. We started off with things like controlling fireworks with a USB port and a laptop. We've done a first-person shooter you can play with a real gun using vibration sensors. Our most popular project to date is our iPhone car, where using the kit of parts from the FRC contest, we were able to rig up a Oldsmobile Delta 88 that we bought on Craigslist for $300 and rig it up so we could drive it from the roof of the car just by tilting the phone back and forth to control the steering, and then we had a slider to control each of the gas and the brake pedals. We've continued to create more projects, things like eye-controlled Nintendo, or we're using biomedical signals in LabView, and we actually have another video coming out very soon featuring real-life Mario Kart. So we're definitely really excited about that one. But we found that Waterloo Labs is a great way to help get people who aren't necessarily already in that technology fold interested, because you know we try to make sure that it's appealing to everyone and that they can see how fun the possibilities in science and engineering can be.
Very cool, very cool. And so now, so we solidify the fact, you created the entire system with an iPhone, iPad?
It was actually an iPod Touch, because that was the cheapest thing to buy.
Okay. All right. So with an iPod Touch and just the parts that were in a FIRST Robotics kit.
Absolutely.
Now, were there any major issues that you ran into? Any difficulties that you had to overcome while you did that?
Finding a car was our most challenging part that we could actually afford, because it had to be drivable, but not that drivable. But because Waterloo Labs was originally started by four of us who were in the phone support department. For 2 years when I started at National Instruments, I did phone support for LabView and Compact Rio. And I'm sure you know there's no better way to learn how a product works than to break it 100 times and fix it. So we were the experts on it. We knew every single problem that could go wrong, and so we were able to preempt a lot of them. The original car that we created, from the day that we bought the car to the day that we finished the video, was 4 weeks. And this was not during our day job. This was all kind of nights and weekends, just trying to be adventurous that way. But you know, with just 4 of us, we were able to do it in a short period of time. And I think it was because we already had all the infrastructure from the FRC kit of parts, so that we could just kind of plug that in. And if you look at the way we designed it, it's actually much simpler than almost any of the FRC bots out there on the field today.
Very cool, excellent. So you're saying one of the kids could actually essentially make their own iPhone-controlled car?
They certainly could. We're obviously a little concerned about that. In the video, we tell them that you know, they can do this, but to be responsible. But the cool thing is we want them to see that this kit of parts is amazingly powerful. That it's not just made for making 4-wheeled robots that shoot basketballs, but that you know, for instance, last year we had a team at Anderson High School in Austin, Texas, which is part of the Austin Cans is the name of their robotics team, and one of their students partnered with a doctor in Austin at the Austin Regional Clinic who had been looking for a way to test a novel design for a knee brace. But for 3 years he had looked to try to partner with venture capitalists and with universities and hadn't been able to find the resources. His son was on the robotics team and he was able to go in there, and in a few weeks these students, using their FRC kit of parts, built an entire system that could test and bend this artificial knee brace and test all the forces on it. Now 2 of those students, the lead engineer was a student named Rita, and she's now a mechanical engineer at UT, just started in the fall. And so it's great to see those stories. She now has a patent pending before even starting college. And so we hope to connect students with that potential and with that capacity for innovation, that they have all the tools they need. They just need to get some ideas and take action.
Very cool. Excellent, excellent. So then, so you're talking about a real-life Mario Kart and things like that. And all these things are besides your normal day-to-day work? Is these are all side projects just for fun?
So it's a little of both. My job is the K through 12 engineering specialist. So fortunately, I get to make things that are appealing to students, which of course Waterloo Labs is included in. Originally, we started Waterloo Labs as kind of our own side project, but National Instruments was very quick to adopt it and fully support us. So now it is a small part of my job, and I do get to continue to do that. Most recently, since the original members who all started in that phone support department are now all in other departments, this past summer we hired 4 interns who came in and completed the 3 most recent projects, including our Connect-A-Sketch, an Etch-A-Sketch controlled by an Xbox Kinect and an Arduino, a Rubens tube, which is a tube that you pump propane in one side, a sound signal in the other, and then we use our National Instruments MyDAC to control it, and then our upcoming project, Real Life Mario Kart, where we basically took, again, the FRC kit of parts and put them onto these go-karts so that we could have a real playable version. That'll be out very soon, and we're excited. And I think it's a testament that we hired 4 undergraduate interns to come in with little to no LabView experience, and in a few weeks we were able to train them up, and with a little mentorship they were able to build these projects on their own, and then I got to just come in and drive some go-karts and make a video. So that part I certainly enjoy quite a bit.
Yeah, excellent. So then when you do these projects, do you set up any sort of deadline for yourself? I mean, you usually say give it 2 weeks, and if not, scrap it, or?
That's always a struggle because sometimes we do have deadlines. Usually at our annual user conference in Austin, NI Week, which is the first week of August, we always try to have a video ready for that. So that's always a good motivator to get the deadline out so that we can show it before our keynote speakers and get it exposed to a lot of folks. But in general, we're kind of on our own schedule. We actually filmed some of the projects this past summer, but have been working on them for several months to get them edited, and basically waiting for the right time to release them, because we want to make sure that it gets out there to a good audience, and that these videos are well loved.
Excellent. Well, thanks for taking a moment to sit down and chat with us, and we'll have lots more coming from the FIRST Robotics competition here in St. Louis.